Hello, welcome to another video on forces this time. What we're going to talk about today is a particular scenario that you might see in a lot of physics questions. So basically it's a pulley on a table. It's a little bit hard to describe other than drawing it, but basically there is a 1 kilo, in this particular scenario we'll go through a 1 kilo mass hanging. And there will be a 4 kilo on a frictionless plane there attached by a pulley. So this might look familiar to a lot of you in a lot of physics questions. We'll go through this particular example and then we're going to generalize it. So instead of 1 kilo and 4 kilos, it's going to be a general question where we can have some formulas for you to work out when we have just M1 and M2 or MA and MB. Okay. Another way we can reframe this scenario is to actually think of it slightly different to what we would usually do, and actually think about it kind of like this. So instead of the force pulling down on the mass, we can kind of stretch it out like that. So pretend that the gravity is acting sideways on that 1 kilo mass, and it's pulling that 4 kilo mass behind it on a string. It's really actually just the exact same scenario, but we're just rethinking it, and it might actually, logically for you as a viewer, it might make a bit more sense thinking of it this way. So it's just really just getting tugged along by gravity, like so. So first of all, when we're looking at this scenario, it's best to think about the whole system, okay? So what we've got there is just that FAG, or the F on A due to gravity, pulling that object, okay? So that's going to equal the net force on that object, because that's the only force acting, which will be MAG times G, which will be 1 times 9.8 or 9.8 newtons. Okay, so from this we can actually work out the acceleration. We know that force equals ma. Now there's a combination of masses involved, so both masses are being pulled by that 9.8 newtons. So it's 9.8 divided by 1 plus 4, which is 5, and you get an acceleration of that whole system being 1.96 meters per second squared. So both A and B, A is kind of accelerating downwards and B is accelerating to the left at 1.96 meters per second. Okay. Now the next bit we might want to find out. Often this is called the tension force, but we want to work out the force acting on B, which is A actually pulling B, so force on B due to A. This will be the only force on B because there's no friction, and so therefore it's the net force on B. So adding all the forces, there's only one force, so it's the net force on B. Now this is just going to be the mass of B times its acceleration, because we know it's the only, we kind of know because it's the net force, it must be the mass times acceleration. Kind of working backwards to work that out. So we've got 4 kilos on B, and we know it's accelerating at 1.96 meters per second squared. So we know that B must have been pulled at with a force of 7.84 newtons. So the force, therefore, or the tension force, or the force on B due to A, is 7.84 newtons to the left. Okay, let's have a look at block A now. So just considering block A, we know the gravity already. We can actually say that the force on A due to B is just the negative, or in the opposite direction, to the force on B due to A, sorry. And that's because of Newton's law saying every action has an equal and opposite reaction. Okay, so A pulling B means B pulls A, and vice versa. Okay. Another way we can think of this, and I've said it before, is that both those forces are the tension force in the rope as well. Okay. So another thing we might need to work out in this particular question, one more thing that we might need to work out in this particular question, is the net force on A. Now, A is the only kind of scenario where there's more than one force acting. This is the gravity force, which is downwards. and also the force on A due to B, which is up. If you think about it, in our reframe scenario, we're thinking left and right in that scenario. So this is just 9.8, which we knew from the start. Force on gravity minus 7.84, which is 1.96 newtons down. So it's a small force because it's a small mass. Okay, so just in summary, looking at those, I've just sketched in there the force on the whole system. Force on A due to gravity is actually the net force total. The tension force in block B will tell us what the net force is on B. And finally, with block A, if we have the magnitude of the force on A due to gravity minus the force on A due to B, or the tension force, we'll get the net force on A. Okay. Alright, let's have a think about this scenario again. So I've kind of just reframed it. If you've noticed this image here, it actually changed. I got rid of the 1 kilo, and I actually changed it to mass of A, and the 4 kilos changed to the mass of B. So we're kind of just generalizing these formulas now. Okay, so these might come in handy. If you see this scenario, you can actually just use these formulas directly. Okay, so from before, we knew the net force was on the whole system was the force due to gravity on A, which is mass of A times G. Okay, now we know the acceleration in total is just the force net on the total mass, or mass A plus mass B. So we can rewrite the acceleration total as being the mass of A on the sum of the two masses times G. Okay, so the acceleration total is ma on ma plus mb times the acceleration due to gravity, which is 9.8. Okay, so that's a quick way of telling us the acceleration total. We could have worked that out before. So 1 on 1 plus 4 means it's 1/5 of the acceleration due to gravity. Okay, which was 1.96. Okay, so for block B, we're going to work out the tension force. Now we're generalizing this, and we know that it's the mass of B times the acceleration total, which will be the net force on B, which also tells us what the tension force is on B. Okay, so this is really just the acceleration times mb. So writing this out again, in a similar sense, we get ma times mb on ma plus mb times g, and that's the tension force. So from the previous question, ma times mb was 4, ma plus mb was 5, so it's 4/5 times the acceleration due to gravity. So 4/5 of 9.8 was actually just 7.84 newtons. Okay, so that checks out for the previous question there too. Okay, and the final bit here, we know the tension force is actually going to be the same. So force on A due to B, the magnitude will be exactly the same there. But the last kind of equation will be working out the net force on A. Okay, and this bit, there's a little bit of maths to it, so it's just going to be the force on A due to gravity minus the magnitude of the force on A due to B, or the tension force. Okay, so plugging all that in, we've got mag take ma times mb on ma plus mb times g, so everything gets times by g. If we do a little bit of maths here, so it's a little bit of algebra here, we can actually find something that's a little bit simpler. Okay, so with the ma times g, what I'm doing is timesing the top and the bottom by ma plus mb, so we've got everything over ma plus mb. So it'll be kind of a big fraction here, and because we have the same denominator, we can then cancel out some of the numerators that are the same. Okay, so this will, I haven't written it here, but ma times ma would be ma squared. ma times mb minus ma times mb means that ma times mb parts cancel out. and we actually get left with ma squared on, if you can see it there, ma plus mb times g. Okay, now this should check out as well from the previous question. It's just going to be 1 over 5 or 1/5 times g. Okay, and that's all for today. Thanks for watching. I hope you've enjoyed the video on this particular Pulley question. Thank you for subscribing in advance. It's really appreciated as always. And definitely leave some comments below. And any questions you've got on this particular scenario or similar scenarios like it. Cool.